Okay, let's have a look at test 1. What is a voluntary response sample? Well, that's the one where the subjects themselves choose whether or not to be included in the study. So like internet, a certain website, you choose to go to that website and they have a survey at the end. Well, that's a voluntary response sample. Or a television channel. After constructing a relative frequency distribution summarizing IQ scores of college students, what should be the sum of the relative frequency? Remember, relative equals percentage. So the percentages should add up to 100, very close to 100. So if we're rounding, it might not be 100 exactly, but the first half of this answer, it's going to either be A or C. Now, if we don't use percentages, if we use proportions, which means fractions, if we add up the fractions, well, they should add up to 1. So if we're working with percentages, which is what we work with, the sum should be close to 100%. But if I was to change those percentages to fractions and add them up, the sum should be 1. So the answer to that one is C. Okay, what is the class width? So this is a frequency distribution. They couldn't put it all in one long list. So this is like the top half and that's the bottom half. It should be a long list. What is the class width? The class width is the difference of any two consecutive lower class limits. So here's two consecutive lower class limits, and the difference there would be 4, so the class width is 4, or any two consecutive upper class limits. So I can see there that the difference between that is 4, so the class width is 4. What are the class midpoints? Well, I have to get the midpoints of each of these classes, so I'm going to add up lower limit plus upper limit. So let me clear that. 32 plus 35 equals, and then divide it by 2. So I have 33.5 for my first one. Then the next one is 36 plus 39, enter, divided by 2. And that'll give me 37.5. And for the next one, I can just keep adding the class width if I like. So I can do those individual calculations for each one, or I can just keep adding the class width. Either way, it's going to get us the correct answer for the midpoints. And so 53.5 is the midpoint for this one. And 57.5 is the midpoint for that one. Now, what are the class boundaries? Be very careful with this because you have to get lower and upper one too. So the first class boundary would be what's halfway between the highest of the first class and the lowest of the second class. That would be 35.5. So I'm going to put it here. What's halfway between 39 and 40? That would be 39.5. So that's my boundary. What's the boundary between third and fourth class? Well, what's halfway between 43 and 44? And that's 44.5. Try and do a focus here, get a little bit better. Halfway between 51 and 52 is 51.5. Halfway between 55 and 56 is 55.5. Now, we mustn't forget the end boundaries. So the boundary on the end would be 59.5. So that would be my upper boundary. And then my lower boundary here would be 0.5 below 32, which would be 31.5. So that's what all of my class boundaries would look like. So there's my class midpoints and then my class boundaries. Okay, so I'll try and keep that calculator at bay. Okay, We have 2,383 people on board a ship that sank, and here's the male survivors, the males who died, female survivors, and females who died. So complete the relative frequency. We have got to find the percentage for each of those. So what percentage of the passengers were male survivors? Well, there were 2,383 in total, so that goes in the bottom. And how many were male survivors? 321, and then I have to take that and multiply it by 100. So 321 divided by 2,383, and then multiply that by 100. And so that gives me 13.47. So I'll take it to, all right, it says round to 1 decimal place. Sorry, I didn't see that. So 13.5. So the instructions said round to 1 decimal place. Males who died, well, that's how many total passengers there were. And how many died? 1,604. And then I take that and multiply it by 100. So 1,604 divided by 2,383 times 100, and to 1 decimal place, 67.3%. Female survivors. So I've got 2,383 total passengers. Female survivors is 338. And then I multiply that by 100. And that'll give me the percentage of female survivors. 338 divided by 2,383 times 100. And I get 14.2 if I take it to 1 decimal place. And then females who died. Well, 2,383 total passengers, and 120 females died. So I'm going to have 120 divided by 2,383, and then times 100. So 5.0 if I take that to 1 decimal place. Now, since I have rounded, I'm expecting this to sum up very close to 100. So 13.5, so that's just a check, plus 67.3, plus 14.2, plus 5.0, and I get something very close to 100. It is 100. Okay, so that's how I know those numbers are right. Okay, the histogram to the right represents the weights of members of certain high school debate teams. How many team members are included in the histogram? Well, these are the weights, and these are the frequencies. So I can clearly see here that there were 2 players who weighed 120 pounds. And from this, that's got to be where 1 is. There was 1 player that weighed 110 pounds. There was 1 player that weighed 130 pounds. Now, how many players weighed 140 pounds? 5 players weighed 140 pounds. And so we've got that. Now, how many team members were included? The answer to that is I add up all these numbers. 1 plus 2 plus 1 is 4. Plus 5 plus 5 plus 5 plus 5. So that gives me 20 and then 4. 24. We had 24 debate team members. Okay, so the given data represents a frequency distribution. Use the frequency distribution to construct a frequency polygon. And then applying a strict interpretation to the requirements for a normal distribution, do the depths appear to be normally distributed, and why or why not? Okay, so if I want to try and do this, I'm going to have, and if I want to try and make my grid, okay, the first frequency is 5. And so look at this grid, 5, 10, 15, 20. So my first frequency should be at 5. So far that one's okay. My first frequency is not 5 for this one, so it can't be that. The first frequency is 5, but frequency polygons have to connect to the horizontal. My first frequency is 5 here as well. So far we're in the running for either one of these. My second frequency is 22. That looks to be right. So we've got the first frequency being 5, and the second frequency being about 22 for the top of that bar. And that's at 5, 10, 15, 20. That's not 22, so it can't be that one. So I could have put these into a chart and could have gotten a histogram and then connect them together. But these little dots here are at the heights of what these are. And this is going to be the only one that fits. Okay. So if I apply a strict interpretation to that, I would not say that is normal because of this guy here. So if I'm applying a strict interpretation to that, the frequency polygon does not appear to approximate a normal distribution because the frequencies do not increase to a maximum and then decrease, and the graph is not symmetric. So it does increase to a maximum here, but then it doesn't continue to decrease here because of this bit here. That would have been more normal than this would be. I mean, yeah, we had a little dog leg there, but a strict interpretation, that would not be approximate a normal distribution if I'm applying a strict interpretation. Symmetric means if you look at one half and the other, you should get something close to mirror images of each other. So out of all of these, that would represent the closest thing to a normal one, but this represented this one, and that's not going to be a strict interpretation. Okay, a nurse measured the blood pressure of each person who visited her clinic. Following is a relative frequency, so these are percentages. So this is 15%. This is 35% because it was a relative frequency. This looks like 25%. This is matching up with 15%. That's pretty close to 10%. And that's pretty close to, say, 4%. Not quite at 5%. This guy, he might be 9%. All right, something like that. Now, approximately what percentage of the people aged 25 to 40 had a systolic blood pressure reading between 110 and 139 inclusive? Between 110 and 139. So they want us to estimate the percentage represented here. Now on these I had to fudge, I wasn't sure, but I'm pretty sure about these numbers. So they're asking us what percentage is in the red box. And so I just add them up, 35% plus 25% plus 15%. So 35 plus 25 plus 15. And that'll give me 75%. Okay. All right, find the original data. Okay, so I have a stem plot. So I have 35, 39, 41, 49, 55, and 55. Okay, and we've got to be really careful. It's that one. Okay, it's not this one because 41's not repeated. Okay, the pie chart shows the percent of total population of 15,700 of Springfield living in the given types of housing. Round your result to the nearest whole number. Find the number of people who live in condos. Okay, 15% live in condos. 15%, not 15 people. 15% of 15,700. And so we take 15,700 and multiply it by 15 divided by 100. Or 15,700 times 0.15. So 2,355 people is our answer. Okay. Listed below are the duration and hours of a simple random sample of all flights of the space shuttle. Okay, let's see if I can get this. Find the mean, median, mode, and mid-range of the given sample data is a duration time that's very unusual, and explain how might that be explained. Well, that looks extremely unusual. This is flight time of a space shuttle, 0 flight time. So, I mean, we could answer that one first. Maybe it's one that crashed or the flight was aborted. So they're on the countdown and they had to stop, like 3, 2, 1 liftoff, but then they stopped or it crashed just after liftoff. Okay. So what is the mean? What is the median? And let's have a look at this. It's not ordered, is it? So let's press the stat and let's clear out list 1. And so let's go to stat and let's put these in the editor. So I've got some stuff in list 2. So I'm going to do 69, 98, 236, 194, 169, 263, 195, 372, 261, 236, 378, 330, and 218, 243, and we must include our 0. Can't leave that off. Now, I'm going to click stat and go and have it sorted. So I'm going to sort list 1 from lowest to highest. Okay, now let's see. What is the mean? Well, let's go to calc. So I'm in stat. Let's go to calc. Let's do 1 var stats with list 1. And I can see the mean is this, and it says to round to 1 decimal place. So my mean is 217.5. Now, what is the median? Well, I just need to scroll down, and the median is 236. Let's do the mid-range while we're at it. What is the mid-range? It's min plus max over 2. Because the min here is 0. The max, scroll down some more, is 378 divided by 2. So 378 divided by 2 is going to be 189. Now, what about the mode? Well, I go back to the list. It only occurs once, only occurs once. All right, 236 occurs twice. So I'm just going to write that down. 236 occurs twice. So it looks to be 236. Okay, now my husband's just come home, so I'm going to put this on hold till the doggy shut up. Okay, now for the next question, we're told to find the mean, median, mode, and mid-range. So I'm going to have to put this into a list. So list 2 is free, so how about I put it into list 2. So I've got 2, 1, 4, 1, 3, 1, 1, and 1 again, 3, 2, 2, 3, 3, and 1. Okay, so what I want to do now is to press Stat and let's sort list 2. And now let's have a look at list 2. Oh, what happened there? Okay, I thought list 2 was free and it's not. My bad. So I should have cleared out list 2 first. Let's try that one more time. I think I did that in class once too. Let's go to the editor. Now, list 2 is definitely empty. It looked like it was empty before because I'd scrolled down through list 1. Okay, so I gotta be careful about that. So we have 2, 1, 4. Oh, okay, 2, 1. Now I'm in a hurry. 4, 1, 3, 1, 1, 1, 3, 2, 2, 3, 3, and 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data values, and I've got 14 data values in that. Now I'm going to sort that. I'm going to sort list 2. And now let's go back and look. Okay, now what's the mean? Well, let's do a 1-var stats with list 2. So the mean is 2. What's the median? Just scroll down. Median is 2. What is the mode? Okay, I've got to go to my list. Okay, the number 1 appears 1, 2, 3, 4, 5, 6 times. The number 2 appears 1, 2, 3 times. The number 3 appears 1, 2, 3, 4. 3 appears 4 times. And the number 4 only appears once. So the mode is 1. And we did not need to use a comma because it wasn't bimodal. So there is a mode and it's 1. What is the mid-range? The mid-range is min plus max over 2. So the minimum value is 1. The maximum value of my data values is 4. And so I'm going to have 5 halves. Oh, sorry, I shouldn't do calculations there. So 5 halves is 2.5. So my mid-range is 2.5, 5 halves. Do the measures of center make sense? Yeah, they make sense. All the measures of center make sense since the data is numerical. Okay, so listed below are the duration in hours, a simple random sample of all flights of the space shuttle. Again, now they ask us to find the range, variance, and standard deviation. And is the lowest duration time unusual? Well, yeah. It is unusual because it is more than 2 standard deviations below the mean. It is unusual. Now, this statement, because the lowest value in a data set is usually an outlier, that's not true. That's not necessarily true. So the correct answer was yes, but not for the reason. Okay, now what is the range of this? Well, we have to put it into our list. So let's get rid of all of our lists. Let's clear out list 1 and list 2. And so let's just put this in list 1. So I'm going to have 71, 99, 240, 199, 168, 261, 191, 372, 251, 231, 385, 335, 222, 248, and then we have to include our score of 0 there. Okay, now I'm not going to worry about ordering this because we haven't been asked to find the mode. Okay, so if I go to calc and I do one var stats with list 1, I can get the range. The range is max minus min. So the range is going to be 385 minus 0. So the range is 385. Now I need variance and I need standard deviation. Standard deviation is going to be S of X in my graphing calculator. So I need to round that to 1 decimal place as needed. So my rounded standard deviation is 105.8. Now the variance is standard deviation squared. But we do not square this. We have to take the actual standard deviation, square that, and then round to 1 decimal place. So we do not take that squared and round because this has already been rounded. So I need to take this and square it and then round it. So 105.79 10339, square it, and then round it to 1 decimal place. And if I take that to 1 decimal place, that'll be 11191.7. Okay, so if you took that and squared it, then rounded it, it's not correct. Okay. A certain group of test subjects had pulse rates with the mean is 76.8, so it's a sample, and a standard deviation of 10.1 beats per minute. Okay, what is the minimum usual value? Usual values are in between the mean minus 2 standard deviations and the mean plus 2 standard deviations. So a usual value is within 2 standard deviations of the mean. So what's the minimum usual value? It's going to be the mean minus 2 standard deviations. So 76.8 minus 2 times 10.1. So 56.6. That's our minimum usual value. And what's our maximum usual value? Well, our mean plus 2 standard deviations. So 76.8 plus 2 times 10.1. 97. Okay. Is 127 beats per minute an unusual pulse? Yes, because this is our maximum usual one, 97. So yes, but that's the wrong reason. It's larger than the maximum usual value. So this should be our answer here. Okay, heights of men on a baseball team have a bell-shaped distribution, so it's normal, with a mean of 172 centimeters and a standard deviation of 6 centimeters. Using the empirical rule, what is the approximate percentage of the men between the following values? Okay, so between 166 centimeters and 178. So there's our mean. And our standard deviation is 6. So one standard deviation to the right is 178, and one standard deviation to the left is 172 minus 6, which is 166. And the empirical rule said that 68% were within one standard deviation of the mean. So, and what about between 160 and 184? Well, if I go another standard deviation, that gives me 160. And one more standard deviation is 6 more in this direction. That's 184. And so now, between 160 and 184, here's our mean. I go 2 standard deviations this way, 2 standard deviations that way, and by the empirical rule, that should be 95 or 97. Let me check really quick. Okay, so I was checking here. The 2 standard deviations from the mean, 95% of them are in the red. What about the heights of women now? It says use Chebyshev's theorem. If it's 3 standard deviations away, however many standard deviations away, then according to Chebyshev's theorem, it's going to be 1 minus 1 over the 3 squared times 100. That'll give me the percentage. So I get 89% have heights within 3 standard deviations of 162 using Chebyshev's theorem. What's the minimum height within 3 standard deviations of the mean? Well, you take the mean and you subtract minimum height, 3 standard deviations, and I get 147. What's the maximum height within 3 standard deviations? That's 3 standard deviations above. So the mean plus 3 times standard deviation. So 162 plus 3 times 5. And that's where I get my maximum. So I had pressed pause and I didn't know where I had undone it. So what would you want your score on your next statistics test to be? Well, I want a z-score of 2 because that means it's 2 standard deviations above the mean. What's the worst score you could get as a z-score? That one. That's 2 standard deviations below the mean. So that's the score I want. Now, what are the z-scores that separate the unusual IQ scores from those that are usual? Remember, a usual score is within 2 standard deviations of the mean. So a z-score, to be usual, it means it's going to be between +2 and -2 because a z-score tells you how many standard deviations you are away from the mean. So the lower z-score boundary for a usual score is -2, the higher is 2. Now they want the actual scores. So I take the mean and I subtract it from 2 times the standard deviation. And that would give me the lowest usual score. The highest usual score is the mean plus 2 times the standard deviation. Which is better, a score of 88 on a psychology test or 59 on an economics test? Well, we just can't say because 59 is lower than 88 that the psychology is better. I have to convert them both to z-scores. So the z-score of the psychology test is the 88 minus the mean of the psychology divided by the standard deviation, which gives me that. The z-score for my economics score is the 59 minus the mean of the economics test divided by the standard deviation of the economics test. I compare these 2 scores, not the 88 and the 59. Now, as far as negative numbers go, between -1 and 0, this is lower. That is the better score. And so that would be my economics test score. It's better because the z-score is better than this one. Okay, now we're up to this. We have 36 sorted ages. Okay. Okay, so I need the percentile value of 32. So for this one, I need to get the number of values lower than 32 divided by the total number of values times 100. And then we just round normally. It says round to the nearest integer. Okay, so how many numbers are below 32? And luckily this is sorted, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values are lower than 32. How many total values do we have? Well, we have 10, 20, 30, 1, 2, 3, 4, 5, 6. We have 36 in total, and I take that and multiply it by 100. So 9 divided by 36 9 divided by 36 times 100. So the percentile value of 32 is the 25th percentile. So at 32, a quarter of the values, at 32, a quarter of the values are below 32. 25% of the data values are below 32 and 75% are above. 32 is the value that separates the lower 25 from the upper 75. Now, let's get P of 30. We have the 30th percentile, and we have to find our locator first. So this is a different type of problem. And the locator will be this number that's indexed, 30, divided by 100, times our total number of values, and I have 36 data values here. So now let me bring in my calculator. 30 divided by 100 times 36, and I get 10.8. And we always round up. So my answer is not 11. My answer is the 11th data value, ordered data value. These are sorted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer is 41. The answer is not 11. It's the 11th sorted data value. Okay, now I need to find the 75th percentile. That's the same as the third quartile. I could put all of these in my calculator and look at the third quartile, but I'd rather just do it. I think this would be quicker. I get my locator, which is going to be this number here, and then multiply it by 36. So 75 divided by 100 times 36. And that gives me 27 exactly. So my locator is the 27. What was the process if our locator was a whole number? Our answer is going to be the average of the 27th and 28th data values in order. So 10, 20, 21, 2, 3, 4, 5, 6, 7, 27, and 28. And if I take the average of those, 67 plus 68 divided by 2 is 67.5. 67.5. That's my answer. Okay, in modified Boxplot, a data value is an outlier. If it's above the third quartile plus 1.5 times the interquartile range, or below this, it's an outlier. So which of the following is not a value of the 5-number summary? The mean is not in the 5-number summary. The 5-number summary is the min, the first quartile, the median, the third quartile, and the max. So which is not, the mean is not in the 5-number summary. Okay. Now we have to find the mean speed. I don't have the original data. I have a frequency polygon. I have a frequency table, a frequency distribution. So I have to get the midpoints here and then have my frequencies. So this is the two lists I'll use. So the frequencies won't change. But I'm going to have to use my midpoints for that. So 30 plus 39 divided by 2 is 34.5. 40 plus 49 divided by 2 is 44.5. So we're going to have 54.5, 64.5, and 74.5. Now I put this in list 1 and this in list 2. So this is what we did in class. So I'm going to do stat. I'm going to clear out, make room for list 1 and list 2. Go back in, and I'll have 34.5, 44.5, 54.5, 64.5, and 74.5. Then I'm going to go to list 2 and put in my frequencies. 5, 18, 52, 15, and 10. Okay, then I'm going to press the stat button, hit calc, Do one var stats, and I must do it with list 1 and list 2. And I see that the mean is 55.2. All right, suppose all the values in the data set are converted to z-scores. Which statement below is true? Well, the mean of a z-score is always 0. Okay, so it can't be that. And it can't be that. The mean of the z-scores will always be 0, and the standard deviation will be 1. So when we convert everything to a z-score, they all have a mean of 0 and a standard deviation of 1. So the answer here is C. Okay, the annual snowfall in town has a mean of 30 and a standard deviation of 11. Last year there was 69 inches of snow. How many standard deviations from the mean is that? Okay. So they're asking us, what is the z-score? So we want to convert 69 into a z-score. So minus the mean all over the standard deviation. So 69 minus 30. 69 minus 30 equals, and then divided by 11. So we have 3.545454, and so it's a positive number, so it's above the mean. If it was a negative 3.5454, that would mean below the mean. Okay, number 27. The ages of the 35 members of the track and field team are listed. Construct a box plot for the data set. Include the values in the 5-number summary in all the box plots. Okay, so we can just put these in a list. And we don't even have to do a box plot. We can look at the 5-number summary. Okay, so let's clear out list 1 and list 2 again. And let's go to list 1. And I'm going to do 15, 16, 18, 18, 18. So I've got 18 3 times, then 19, then 20, then 20, then 20, then 21, 21, then 22, 22, then 23, then 23 again, then 24, 24, 24, then 25, 25, then 26, then 27, 27, then 28, 29, 29, 30, 31, 31, 33, 34, 35, 39, 42, and 48. Okay. And let's ask it to do 1 var stats. And so let's look at our 5-number summary. Of course, we know that the minimum is 15 and the maximum is 48, and they all have that. But I've got 20, 24, and 30 for my first quartile, median, and third quartile. 20, 24, and 30, and that's what I need. 20, 24, and 30. That's this one. 20, it's Q1, 24, and 30. So I have min and max, but they all had the min and max. Okay, the last thing, we need to construct a modified box plot for the data. Okay, instead of putting all this in, let's see if we have any outliers. First of all, let's see if 1.7 is or is not an outlier, because I would be able to cut it out by half. Okay, so we've got another question here. A data value is an outlier, number 22, if it's below Q1 minus 1.5 times the interquartile range. Okay, so I'm going to have to figure that out anyway, so never mind. Let's put this in list 2. So I've got 1.7, 2.0, so I'm just going to write 2, 2.2, 2.2, 2.4, 2.5, 2.5, 2.5, 2.6, 2.6, 2.6, 2.7, 2.7, and 2.7 again, then 2.8 3 times, then 2.9, then 2.9 twice, then 3.0 twice, then 3.1 twice, then 3.3, then 3.6, and 4.2. Okay, let's have a look. And we're using list 2. Let's get the 5-number summary. Okay, so they all have the right min and max. They all have the correct first quartile, median, and third quartile. So we have to check. So what is our minimum to be not to be an outlier? Well, that'd be Q1 minus 1.5 times the interquartile range, which is Q3 minus Q1. So Q1, which is 2.5, minus 1.5 times Q3, which is 3, minus Q1, which is 2.5. So 1.75 is a minimum that's not an outlier. Okay. And so where is 1.7? 1.7 is below that. So 1.7 is an outlier. So I can rule this one out because it's showing it not as an outlier. I can rule that one out. Okay. Now, if I didn't have the multiple choice, I'd go on and ask myself, well, is 2.0 an outlier? No, it's not. Okay, so now look at these two. We know from the 2 remaining choices, 4.2 is an outlier. So we just need to check if 3.6 is one. So what is the maximum that is not an outlier? Well, that's going to be Q3 plus 1.5 times the interquartile range, which is Q3 minus Q1. And Q3 is 3 plus 1.5 times Q3 minus Q1. So that will be 3 plus 1.5 times 3 minus 2.5, close parentheses. So my maximum value that's not an outlier is 3.75, and anything above that is an outlier. So what have we got? 3.6. 3.6 is inside, so it's not an outlier. 4.2 is an outlier. And so that's matching up with selection D. So the answer to number 28 is selection D. Okay, that concludes the review to the test.